In this video, we'll answer the question whether XeCl2, this is xenon dichloride, is polar or nonpolar. So we want to know if this is a polar molecule. We have our Lewis structure here, and you can see xenon has more than 8 valence electrons, but that's okay. It has an expanded octet. And it's kind of strange. Xenon is a noble gas. We don't usually think of xenon as forming chemical bonds, but under certain conditions it will form bonds. So this actually is a compound that exists. These electrons here are shared between the xenon and the chlorine. Let's change that to a line just so it's clear that that's the bond. So this is a valid Lewis structure for xenon dichloride. To understand whether we have a polar or nonpolar molecule, let's first look at the bond, these electrons here that are shared between the xenon and the chlorine, to see if there's a difference in electronegativity. So here's chlorine 3.16, and this periodic table actually lists the values, the electronegativity values for the noble gases that form bonds. And xenon is 2.6. So there is a difference in electronegativity. Chlorine is more electronegative. And because of that, the chlorine atom here, the bond between the xenon and the chlorine, the electrons in this bond will spend more time around the chlorine atom. Same thing on this side. Let's go back to our Lewis structure. So we said there is a polar bond between xenon and chlorine, but we need to look at the molecular geometry to understand if the molecule overall is a polar molecule. Let's take a look at that. We'll consider the purple atom our xenon. Let's add our 2 chlorines, 1, 2. They spread out to be as far away as they can from each other. And remember, we have those 3 lone pairs, 1, 2, and 3. And what ends up happening is we have a symmetrical molecule. The chlorines here, they're pulling in opposite directions, so they cancel out. So we don't have a net dipole. So this means that XeCl2 is a nonpolar molecule. So let's go back to our Lewis structure, and we can say that we have a polar bond between xenon and chlorine, but overall, the electronegativity difference, the dipoles, are pointing in opposite directions. So overall, XeCl2, that xenon dichloride, is a nonpolar molecule. This is Dr. B, and thanks for watching.